Thank you for coming back to Uncle Pang's lessons. Today we are going to touch on the story of a spring balance in a lift. Just remember, don't treat physics like one of the science subjects. You know what I mean? Actually, physics is a game. And I'm going to introduce this game to you afterwards and show you that how some of these forces, some of this acceleration, mass in a lift, we can treat it like a game and you can understand it very much better. Now, to do well in physics, once again, remember the key is doing output revision, which means that you have to answer past year questions, you rehearse, you write down, you do your calculations. It means that it is not input revision. Input revision is just reading and reading, alright, which does not help very much. Do output revision. That is the best. At the end of today's lesson, you should be able to solve problems involving forces, mass, and acceleration in a lift. Let's take a look at the question. Diagram 6 shows a load hanging on a spring balance in a stationary lift. The reading of the spring balance is 20 newtons. Now this is the story. Alright. Allow me to show you the gadget. It is something like this, isn't it? So we have a spring balance and we have a load, and then this is stuck to the lift. Alright, you can take this, go to one of the hotels, go to the lift and try it out for yourself. Alright, so this is the story. Just focus in your mind. Now, what is next? The question says, what is the reading of the spring balance when the lift moves up with an acceleration of 2 meters per second per second? In other words, the spring, it accelerates upwards. It moves up. Alright? Okay, let's see how to calculate it. I'm going to explain to you like a game. Remember, I said physics is like a game. And I'm going to show you how. Alright, I'll go to the diagram again. Now write down a few important things. In the question, it says that the reading of the spring balance is 20 newtons in a stationary lift. 20 newtons. So what does this mean? Weight of the load is 20 newtons. So what is the mass? Now mass times G, alright, I just write this down first. Weight is equals to mg, the formula, mass times the acceleration due to gravity. Weight equals to mg. So now we are given the weight 20 newtons. We are given g, formula page 10 meters per second. You need to know the mass first. Alright. So what is the mass of the load? Alright. What is the mass of the load here? It is equals to weight divided by g. Okay. So what do I have? I will have weight is 20 newtons. I divide it by g. G is 10 meter per second. So what do I get? I will get 2 kilograms. Alright, so that is the first step. I'm going to write it down here. Alright, so this is the diagram. This is the question. I'm going to write it down here, everything. So the mass of the load is 2 kilograms. So far so good? Alright. So in the question it says, alright, the lift moves up. Moves up with acceleration 2 meters per second. So I'm going to indicate it. Alright. So the lift, it moves up. Alright. the acceleration is 2 meter per second per second. Okay, so remember, acceleration, I've got to put an arrow here because we are talking about up or down. So acceleration upwards equals to 2 meter per second per second. Now just remember that what we are talking about here is just like, I'm going to draw another diagram that makes it easier for you. This is the spring balance, this is our load, and then this is the weight. Okay. Now in this string, there is a tension, isn't it? There is a tension. I call it T. And actually the tension gives the reading in the spring balance. The tension is actually the force in the spring balance. Okay. So the tension, the weight. And remember now, this system, there is an acceleration upwards. Alright. Focus on what I have just done for you here, because I'm going to ask you questions here. So I have summarized the story in this form. Okay. Now look, please look at this. Alright. Look at here. Look at this. Now the system is moving up or down? Up. Okay. So how many forces are at work? 2. T and the weight. Got it? There are 2 forces at work. And it is moving up. And remember that T and weight, they are opposing each other. The T and the weight. So I ask one question and I would like you to also write down this question. Because this is a very, very important question and it will help you to understand this concept. Write down this question, please. Who wins? Who wins? T is competing with weight. The whole system is going up. So who is the winner? Is it T or weight? I'm sure you know the answer, right? Okay. So since it is going up, T wins. Alright, my answer is T wins. Alright. So the tension is the one that wins. Alright. So tension T is the winner. Alright. So I'm going to write down, since T is the winner, T must be bigger than weight. So by using what we have studied in terms of net forces or resultant forces, you will know that T minus weight, minus the weight, this will give us MA. Resultant force equals to MA. Now this shows us that you must not try to memorize everything in physics. You try to understand, you try to reason it out like a game. Alright, ask the question, who wins? Alright, so T wins, T is bigger than weight. And T minus the weight, it will give us MA. Good. So now we fill in the blanks. We want to calculate T actually, because the question says, okay, let's take a look at the question. What is the reading of the spring balance when the lift moves up with an acceleration of 2 meters per second per second? In other words, the reading of the spring balance here, alright, so this is the T that I'm talking about, okay? So let's go back here now. Let's go back. So T minus the weight. Just now remember we wrote down the weight. How many newtons is it? 20, alright? 20 newtons equals to M. M is the mass. You refer to what you have written down. It is 2 kilograms. And what is A? It moves up 2 meters per second per second. Alright? Now it's simple mathematics. Two times 2, alright, equals to, okay, I'll just put this. Alright, this one, because I don't want to multiply it yet. Kilogram times meter per second gives me newtons also. Alright, so what do I have? I have now 24 newtons. In other words, as the lift goes up, the reading increases. Alright, or rather as the lift accelerates up, it must accelerate. Okay, when you say it moves up, what kind of motion? We must be specific. When it accelerates up, then we get an increase in the reading. You must be specific. Alright, so having done this, we have worked out the answer. We know that the reading in the spring balance, alright, reading in the spring balance you can take this away. Therefore, the reading in the spring balance is equal to 24 newtons. Because earlier up here, I get 24 newtons. Simple, isn't it? So it is like a game. Alright? So, I'm very sure that after this explanation, you are now able to solve problems involving force, mass, and acceleration in a lift. Go and pick out other questions and answer more questions, then you will be more steady and you will be bulletproof. Okay? And with this, I would like to say thank you very much again for being with me. Bye.